While we're on the subject of fixes, let me address a long-standing complaint of respawning in our little game. Sometimes when we respawn, we end up at the same spawn point that's already occupied by another tank. Now once gameplay begins, the players' colliders will force them away from each other, but it's still an unpleasant experience. Now undoubtedly you've encountered this, two tanks picking the same spawn point. I just wanted to show you a simple, if incomplete, solution to this problem. Now it's not necessarily anything that has to do with networking specifically. You could easily implement something like this in a single player game. What I'm going to do is put a sphere collider on each spawn point. And I'm going to make the collider a trigger. Now a trigger basically is going to act like a sensor for any physics objects that enter, stay, or leave. But it doesn't impede physics movement. So your tanks are free to come and go, but the trigger knows when something occupies its volume. So let's drop a sphere collider on one spawn point. Let's take a closer look at it. I'll dial the radius to something like 3. And now it's large enough to go off screen. So let's pull the camera out. Make sure that you check is trigger. Copy the component. And then paste the component as new on the other two spawn points. I only have 3 spawn points, so it's no hassle. But if you had to do a lot of these, you would just make the spawn point into a prefab, and then just apply the changes to the prefab. Everything looks good so far. We'll need a new C# script to handle the logic of detecting player tanks. Let's call it spawn point. I can either drag it out or add it via the menu, either way. I want my new spawn point component attached to the spawn point object. Okay, let's edit the class. And I can clear out the start and update methods. Our spawn point will be rather simple. It doesn't really have much use for start or update. I need one public boolean called m is occupied, and I'll default that to false. Because we have a collider attached to our object, we can use mono behaviors onTriggerEnter, onTriggerStay, and onTriggerExit to change the value of m is occupied. Let's do onTriggerEnter first. We always pass a collider into onTriggerEnter, and that's the other collider that makes contact with the sphere collider. So I'm going to call that other. If the tag of the other collider is player, and I'm just going to hard code it to keep it simple, then we set m is occupied equal to true. And I'll basically just repeat this whole thing for onTriggerStay. Every frame that a player tank stays within the volume of our trigger, then m is occupied is true. And the only way to change the state of m is occupied is for the player tank to leave. And so we'll do that in onTriggerExit. Every time a player tank leaves the trigger, we change m is occupied and set it back to false. Now in the event that more than one tank is in the volume of the trigger, then onTriggerStay would actually set the m is occupied back to true. We can try it out once I attach the spawn point component to the other spawn point objects. So let me copy the component, and then I'll paste the component as new on the other spawn points. Okay, that's one. And then on spawn point 3, paste component as new. I've set my minimum players to 1 in the game manager, so I can drive around without having to build 2 clients. Let me just press play, and I'll highlight the spawn point objects in the hierarchy so you can see them in the inspector. As my tank drives into the trigger of the spawn point, you can see the m is occupied change to true. And then when it leaves, m is occupied becomes false again. Now we need to take advantage of this fact. We currently respawn in the player controller component, so let's take a look at that. It's down here at the bottom. We have a getRandomSpawnPosition method, and it basically finds a random network start position and then returns its vector 3. Essentially, we just need to adjust this method to check for a random spawn point and only return its vector 3 position if the spawn point component M is occupied is false. It's going to start and end the same, but we need to add some logic in the middle, so let's make some space. I'll reserve a boolean called foundSpawner, and we'll default that to false, of course. I'll also reserve a new vector 3, and we'll call it newStartPosition, and I'm going to use these in a while loop. While foundSpawner is false, let's just move this old line into our while loop. We'll select a random network start position, and then we'll check the spawn point component of that. If M is occupied of that spawn point is false, that means the spawn point's empty. And that also means that foundSpawner can be set to true, and our new start position is the position of the spawn point's transform. And then after this code block, we return newStartPosition. And then we can clear this old line and then just clean up some white space. The bottom of our method is just our catch-all. If we don't have any valid spawn points on the level, then we return the original position that we appeared in the maze. If we use a while, we always introduce the possibility of an infinite loop, so we have to be careful about that. That'll lock up your application, so it's always good to build some kind of timeout. I'll set it equal to the current time plus, say, 2 seconds. Down here in our while loop, we just check our time. If time.time is greater than timeout, if our loop happens to be spinning in an infinite cycle, then this will help us break out. If we can't find an empty spawn point after 2 seconds, then let's just spawn at our original position. We'll just force foundSpawner to be true, and then set our new start position equal to M original position. Of course, there's always still one more complication. If you destroy a tank while it's in the middle of a spawn point, we have to account for the fact that we haven't set our spawn point's M is occupied value to false. Because we instantly transport the destroyed tank to a new location on the board, the physics engine never gets to run onTriggerExit. Now we need to fix the isOccupied value during the respawn routine. Otherwise you're going to get some phantom occupied spawn points that never turn back to being vacant. First, let's make a little helper function to figure out if the tank is currently occupying a spawn point when it dies. And I probably should name it something else, but right now I'm just going to call it getNearestSpawnPoint. It takes no arguments and returns a spawn point component. I will set an array of colliders called trigger colliders equal to the physics overlap sphere. And then that's going to check for any colliders within the volume of the sphere. I'll center the overlap sphere at my current transform position. And I'm just going to arbitrarily assign it a radius of 3. I'll use all the layers available. And I want to make sure that I include colliders that are currently set to be triggers. That's really important since our spawn points are triggers. So we need to add a query trigger interaction set to collide. Now once I have an array of colliders from that sphere, I just loop through each one with a for each, and I'll check each one if there's a spawn point component. If there is, then great. We just return the first one that we encounter. Now if we loop through everything and we haven't found a spawn point, then we just return null at the end. Okay, to use this, I'll go to my respawn routine, and then I will find the nearest spawn point and store it before we move our tank to its new location when we die. Now we should be dead at this point and hidden from view. After we move to a new random spawn point, we just make sure that if we did have an old spawn, and that means we were killed while we're making contact with a spawn point, Then we switch the spawn points and is occupied to false. Okay, this isn't a perfect solution, but it should handle probably 90+% of the cases. Now, with some luck, it should be hard to spawn at an occupied spawn point now. Now, if more than one tank occupies a spawn point when you destroy one of them, then the spawn point will be incorrect for one frame until the next frame when on-trigger stay can be invoked. But for the most part, it seems to work for respawning. In this example, I have 2 tanks and 3 spawn points, and after a few minutes of shooting at each other, I was always getting the tank to respawn at a vacant spawn point. Okay, respawn is the active word here. This code does not affect the very first spawn in the game, which is actually handled by the network manager. Remember that we have this random and round robin option in the network manager for spawning our tanks? That still applies. Now, you could script the network manager to handle this logic as well. You would just basically extend the network manager class and then use a custom class with similar logic when you go to spawn your player prefabs. Now, we aren't currently doing that because in the next lesson, we're actually going to have a fairly drastic change to our network manager because I wanted to introduce Unity's network lobby, and that's going to replace the network manager as we know it. Okay, so stay tuned for all this exciting stuff in a future episode.